Struggling with network outages, security breaches, or poor performance in your LAN? What if you could design a scalable, secure, and efficient network architecture like a pro? In this video, I'll break down the 3 critical layers of a LAN: access, distribution, and core, and show you how to avoid common pitfalls that lead to costly downtime and inefficiencies. Whether you're an IT professional or just managing a small business network, these tips will save you time, money, and headaches. Ready to optimize your network? Let's dive in. Access layer, distribution, and core. In a LAN, there are 3 types of layers. The access layer, which provides endpoints. This is where users have direct access to the network. There is the distribution layer, which includes the access layer and also provides connectivity to the services, and the core layer, which gives connectivity for the distribution layers. Very useful in large LAN environments. A company can only work very well with 2 layers or with all 3. For example, a site that occupies a single building will only need the access and distribution layers, while a multi-building company will likely need all 3 layers. The access layer is for the termination or endpoint devices, which are connected to the network. It provides wired and wireless connectivity, as well as features and services that ensure the security and smooth operation of the network. The access layer provides connectivity with very high bandwidth so that it can support a spike in traffic when users are multitasking on the network. It can be, for example, sending an email with large attachments or opening a file on a remote server. When designing the access layer, ensure that the network is available to all users who need it. It is the connection point between the network and the clients. It should help protect the network from human error or malicious attacks. That is, it is necessary to ensure that users only have access to authorized services and prevent them, for example, from pretending to be another device on the network. The access layer provides a set of network services that support different technologies, such as VoIP or video. It must provide them with dedicated access so that traffic is not disrupted by other devices. It is also the access layer that ensures the efficiency and proper delivery of traffic. The distribution layer supports many very important services. In a network where connectivity runs across the LAN from end to end, such as between different devices in the access layer, the distribution layer helps facilitate this connectivity. This is the layer that provides regulated connectivity. It is in this layer that IP routing works, both static and dynamic. The distribution layer helps to provide scalability. In a network with more than 2 or 3 access layer devices, it is not very practical to interconnect them together. Well, the distribution layer serves as an aggregation point for the access layer switches. This reduces operating costs by making the network more efficient. It also increases network availability by locking up the risk of outages in smaller areas. Now, let's move on to the topmost layer. In a large LAN, you often need to have several switches that are part of the distribution layer because they are often located in different locations or even completely geographically dispersed. To save lengths of optical fibers that are quite expensive, it is wiser to put a distribution layer equipment in each building. And if the networks exceed 3 distribution layer devices in a single area, then it is better to use the core layer to centralize and optimize the design. The central layer, also known as the core layer, is the essential part of a scalable network. And what's more, it's the simplest design. The distribution layer segments the network, and the core layer allows for 24-hour connectivity. This connectivity is essential for any business. A poorly designed network can greatly increase management costs caused by several network outages, and poor performance directly affects end users and their access to different resources. Network architecture issues. We will see several types of problems that can be found on poorly designed networks. There can be broadcast problems, even if they exist in all networks. In fact, many applications use broadcast to work properly, so we can't eliminate them completely. On the other hand, we can define certain limits to confine them to a smaller area. Management difficulties can also be encountered because with a poorly designed and poorly documented network, traffic flows can be difficult to identify. This makes maintenance and problem solving very difficult. On a poorly designed network, there are many weaknesses in terms of security. If the network has been designed with little attention to security, then the access layer could cause big problems on the entire network. And we can have various other problems more or less extensive. One of the main reasons to implement a good network architecture from the beginning is to minimize the extent of problems when they occur. That's why it's important to clearly define boundaries between Layer 2 and Layer 3. That is to say, between a switch and a router, because otherwise any network problem will spread far than expected. A poorly designed network always has a negative effect. It becomes a burden for the support. But it's also a financial abyss for any company.